guys, I'm Sean from Bluehub, and today I'm going to be covering importing production bombs. So there are a couple of things I want to cover here. Firstly, the way a bomb is connected to an inventory item, because there is a lot of confusion around this. I've worked with several clients where they don't quite understand how the bomb is linked to the actual inventory item itself. Secondly, the bomb structure, so that's going to be what actually makes up the bomb. And finally, how you then import that bomb. So starting off here, if I go into my inventory and then go into my products, and select any given product, for example this one here, we load up this set of attributes for that item. If we look down on the left side here, we have the option for bill of materials. So that's going to be your actual bomb and the components required to create that product. Within there we have three different options: assembly bomb, production bomb, and make to order bomb. An assembly bomb is going to be the easiest to create, and that's going to be a bomb that just requires a main item and then components. And this is usually if you're shipping out 3 or 4 items, but you want it to show up on an invoice as one item. So for example, some people do it with bundles. So a bundle containing a book, a drink, and some sweets. You put those together in the box, and that's going to be shipped off as a single assembled item. So that item's going to need its own SKU, which would be the one given above. So if we then were to enable that, we could then list below the 3 different items that make up that, which would then get consumed when we ship this item out. We then have our second option, which is our production bomb, which is a more complicated version of our assembly bomb because it's going to be used for manufactured goods. Within here, we can decide things like cycle times, wastage amounts, different like operation types such as co-manufacturing, manufacturing, or quality control. We can add different sequences, so there are multi-step bombs. We can add resources, so we can add different labor costs or machine costs, things like that. There's a lot of benefits to using the production type bomb, and that's that it's going to track a lot more data. However, the downside is it's a lot harder to process a production bomb, and it's also going to be a lot harder to set up. So these are some of the things you have to take into consideration when picking between your production and your assembly bomb. Then finally, we have our last option here, which is make to order bomb. And our make to order bomb is going to be, as it implies, one bomb, the bomb decided upon the order. So you can't create these to stock. They're going to be created on the order line, and they're going to be able to have different options picked for the user. So for example, they may come in different colors, they may come in different sizes. But on a sales line, you'll be able to click configure, and you can be able to customize that one to be created for that specific sale. You'll then have to do the production run to create that item that is unique to that sale. So today I'm going to be covering production bomb and how you import that specifically. So as we can see here, we have our main item, and then we have production bomb enabled. This doesn't mean it's automatically a bomb. We then have to go into production bomb and apply the components and steps required to actually make it. Within here, we'll use different components, but they already have to exist within the inventory. So these can't be made up items. They need to be already existing stock items within the inventory. The same can be said about the bomb import sheet. We can't just add items there and then it'll import as an inventory item. We need to be using items that have also been imported into the inventory. That is probably the hardest thing for some clients to get. So really try to digest that and, wrap your head around the fact that the actual bomb itself is just a reference to current items that already exist. Now that we've took a look at the bomb structure in the UI here, we'll move on to the actual import sheet, which is what today's video is going to be about. So if I pull that up like so, here we have our actual import sheet. So starting from the left, I'll make my way through these and explain what each of the headers means and what possible values we can have inside of that. So starting on the left here, we have our product SKU and product name. So that's going to be the reference to the main item that this bomb is going to link to. So for example, if we went back to our Chrome tab, that's going to be this SKU and this name here. It's going to be the product that's going to be created based on this bill of materials. So hypothetically, you would never be purchasing in this bike. You would always be building out of components you currently had. We then have our buffer percentage, and this is a time-based thing. So saying if you said, for example, it takes you 24 hours to build a bike, the 10% or percentage that you add in here is going to determine the amount of additional time you get on top of that. So, for example, I've added 10%. So On top of your 24 hours, you'd get an extra 2.4 hours. You then have our quantity produce, and that's going to be how many we're going to want to produce per order. So currently we have 1. So when we complete one of these manufacturing orders or manufacturing runs one time, it's going to create 1 product. We then have the option to add in an instruction URL. So this is for any employees. So if they don't know how to build that product, they can click on a link. It's going to take them to a web page, and then it's going to give them instructions on what they need to do to actually assemble that. We then have ignore cumulative lead time, and that can be either true or false. And what it's going to be doing is if it's on false, it's going to use the lead times of all of your different products that are being brought into this main product, and it's going to use them to calculate the overall lead time for your finished good. If you ignore this, it's not going to use any of the lead times for those products, and then you can just set a lead time on the right of whatever you would like it to be. So where I can see this being useful is if you had 5 products that you need to build this bomb. One's got a 4-hour lead time, one's got a 5-hour lead time, another's got a 4-hour lead time, and the final one has a 10-hour lead time. Since the 4 and the 5-hour lead times may not matter, you may always want that lead time to be 10 hours. So over here on the right, you just put the 10-hour lead time, and then all of the other products would be delivered by that time the one item had been delivered. So that's how that works, and one use I could see for it. However, obviously that's up to you if your business would want to use that and how that would fit in. We then have different versions for our bomb, so we can have as many versions as we'd like. First, we need to give that version a number, so 0.1, 0.5, 1, 2, 5, 10, etc. We can then apply a name to that version, so here I've done beta, however you can name this whatever you like. So you could have different bomb versions for different colors, you'd have different bomb versions for different components that needed to be used. And what it's going to allow you to do is per set of version, you can just add an entirely new bomb against the new version, and it's going to store itself in a different location, so you can essentially have 2 of the same bomb. You can then alter one to meet different requirements or different demands. The only issue with this is if you have 2 of these versions in stock, if they're not being batch tracked, you may have issues determining which stock is one version and which stock is the other version. So I'd be careful about that. Next we have our version default, whether this is our main version, true or false. If it's true, then this is going to be the version that automatically populates when we load our bomb. If it's false, and it's going to not be the one that automatically populates. However, if it's the only one version available, it's still going to be the one that populates. But if you had 2 versions and one was true and one was false, even if the number of the bottom one is lower, it's still going to use this one because this is the main version. We next have our Minimax Quantities, and this is just a minimum and maximum quantity warning we'll get when doing our run. So for example, if your workshop only had enough space to build 2 bikes at a time, you would set the max quantity here to 2. So the minimum you're ever going to build is 1, but you can only fit 2 to build, so you're only ever going to build a maximum of 2 bikes. For this, it's not actually going to stop you from doing your production run if this errors out. It's just going to give you a warning and say that you're not actually able to continue. You are able to continue, but it's not going to work very well because you don't have space. So it's up to you whether you continue that on anyway or not, but it will warn you about it, so that's quite useful, especially if you're doing proper capacity tracking within DIR. Here we have our deviation percentage, and this defines how far you can stray from the deviation on the left. So if you have no number in here, you're allowed to deviate as much as you want from this. But if you have 0 in here, you have to stick into these values, as I was just saying about the errors. If you have 0 in here, I believe it will keep you to this, so you'll only ever be able to produce 1. Next, we have run size. Run size is going to be how many products you're going to produce in a run. So this is just going to default to 1. Next, we have operation sequence, and this is for multi-step bombs. So if we have, for example, a step of building the bike, and then a safety check step to make sure everything's properly secured, that would be a 2-step bomb, and we'd have a sequence of 1, and then a sequence item of 2. We can then pick the types of these sequences. So our first sequence is manufacturing, where we're going to be building the bike, and then our second sequence is quality control. Out of these sequences, we have these 4 options, which include setup, quality control, manufacturing, and co-manufacturing. Setup and quality control are just going to be your just allocating a resource to that time, just so that we can set up the area, and then we can quality control, and we can calculate the cost for that labor in doing that process. And then manufacturing is going to be any internal manufacturing required to make that product, and co-manufacturing is going to be any external manufacturing required to make that product. When it comes to any external manufacturing, we're going to have to set up a co-manufacturing BOM, and then what it's going to do is it's going to make us pay a service charge to get our finished goods. We also have the option then to do buying or transferring co-manufacturing, and that's whether we're going to buy the raw components for that BOM off of that co-manufacturer, or we're going to transfer the raw components for them to build it and then send it back. Now we have our operation name. We get to name those sequences. So here I've just done build and safety check. This is going to be the building of your bike, and this is going to be just checking the safety, as I just said. So you can name these whatever you want, and that's just a reference for you internally to help know what that stage is. We then have our cycle times. This is how long that stage is going to take. So it's going to help with your capacity planning. So if I say this is going to take 1 hour, and then I build the bike, and then I set up a build for a bike, it's going to say that 1 hour is going to be taken out of that day, where we can't use that staff because they're too busy building this bike. It will then help you calculate your forward planning, so you can see that in 1 day you're only going to be able to build 8 bikes, and you can then start planning out your production orders based around that. We also have the second stage here, which takes an extra 10 minutes, which means overall this BOM is going to take 1 hour and 10 minutes. We then have our units per cycle here, and what that's going to determine is, once again, how many of this, I just have to double check that, and it's going to calculate the number of total units produced in that cycle. So, for example, it's going to calculate it for manufacturing or your co-manufacturing here. So basically, if I was going to build a bike, I may be producing 2 units. However, if I was going to be safety checking those bikes, I may be safety checking 4 bikes at one time, for example. Next, we have our work center code. And this is like an SKU for a location where work or where production is going to take place within DIR. This one needs to be set up on the back end, and then you can allocate resources, aka labor, and also plan your capacity around that location. For example, we have garage and park in here, and then here we have our garage and we have our park. So yeah, basically that means that these are 2 work centers within DIR, and we're assigning these projects to take place in those locations. We then have our components / resources being used here, so this is anything used within the BOM. We have a couple of options for this, such as inputs, outputs, components, resources, etc. But the main ones we're going to need to know for now are components and resources. A component is any physical item being consumed by that BOM, aka the wheel, chassis, chain, paint, etc. And then a resource is any labor cost or machine cost, anything that isn't an actual physical item that's being consumed when making that product. On the right here, we have the option for our quantities. So we can have 2 wheels, for example, being used to make this BOM, whereas we only have 1 chain being used to make the BOM. We then have the options here for any wastage that we know is going to be used every single time, and we can calculate that either by percentage or by the amount of stock being consumed. So for example, we could have 1 wheel being wasted every time we made a bike, or 50%, so also 1 wheel every time we was making the bike. So 50% of our stock would be wasted, so we would effectively waste 1 wheel. Moving on, we have our cost allocation type, and that's going to involve how the cost is actually calculated for the overall BOM or sellable product. And there are 2 options for this. We have NRV, and then we also have sales value. Now NRV is going to be your net retainable value, I believe. And what that's going to refer to is the overall value of all of the items that have gone into that product. Whereas our sales value option is just going to make the cost of the item worth the same as a sales value tier. We can then select the tier of that sales value on the right here. So for example, we could have this product cost be the same as its sales value tier 2. We can then sell it for sales value tier 1 to make our profit. We then have cost of wastage, so the cost of the components here, how much that wastage is going to cost you, and it's going to be based on the sales value of those components. So, for example, if our wheel sold for £20 at sales tier 2, it's going to, and we waste one wheel, it's going to cost us £20. But if it was £28 at sales tier 1, it would cost us £28 if we change this to sales tier 1. We then have our delivery to location name. So that's a location that already exists within the system as the value it accepts, and that's where the item is going to be delivered to once it has been created. So where our bike is going to end up after it's been finished. So here I've just put in storage. However, you'd put any location where your goods were going to be stored after production had finished. We can then select the bin that we'd like them to go into. So I've selected bike rack here, but you will probably have a more complicated bin structure. We then have an option here for co-manufacturing price here for our co-manufacturing bombs if we ever use them. And what that's going to refer to is the service cost of our actual co-manufacturing charge. So when we have our charge against our co-manufacturing service, so say £50, we can assign a different cost to each price tier for that service. So service tier price 1 would be £50, whereas 2 may be £75. And we can determine which one of those values we use here. So we can have one service for multiple bombs, and we can just use its different tiers. We then have the option for product traceability here. This is just going to allow you to trace your products throughout the system. I'm not too sure, I think this may just be a free text field. I'd have to look into this one, but we'll come back to that another day. We then have our issue method component. So there's two options here, manual and backflush. Manual as if you manually determine your issues and then you fix them manually. Backflush, I believe, just reverts all stock to where it was prior to the issue, although I'd have to double check that. So I would look into that yourself if you were looking to use that backflush functionality. The following options are all for backflush and setting that up. And then finally, we have our resource cost type on the very right here, which is going to be how we're going to charge for our labor costs. So we can either have that cost per unit time or cost per unit hour or cost per finished product. So if we're charging our labor per finished product or paying them for per finished product, we can have that. Or if we're charging them per set unit amount of time, we can also do that here. That time is then determined on the actual resource within Deer's settings. So if we're doing per unit time, we can have that time be 1 hour, 2 hours, half an hour, etc. Whatever we'd like that to be. So that's going to be everything in terms of the actual fields you'll need to fill out for the import. Once you're happy with all of that, you want to come onto your Deer like so, and then go into your inventory, go to your products, click import, and then import production bomb. If you click the field specification here, you can get another list or explanation of all of those fields that I just went through briefly, and this is Deer's description of them. I'll warn you that some aren't that great. I've noticed some errors when I was in here in the past. However, they may have fixed that now, but it's up to you on how you want to use these. You can also go to the Deer's webpage to get more detailed explanations of these, and I may recommend doing that. It also tells you which fields are mandatory up top here. These are the required mandatory fields, and then below are your optionals that you can add in. However, some of the optional fields may become mandatory based on your these fields here. So for example, if you was to use one field, it may make another field mandatory. Once you're done with your import and you've got all your data, you can then drag that file into here like so, and then that will then import your bomb. It will also display any errors you have, so they'll populate here and you'll be able to go through and sort out any errors based on Deer's feedback. Hope this video was helpful. I'll catch you next time, and that'll be all. Goodbye.